This film reviews my review of the various structural members put into this house, in particular the section in the middle here. But so that you know what the house looks like when it's put together, our concern is largely this piece in here. Before I get down to the crawl space and what is happening down there, with regard to this bit up here, the roof loads, anything with the roof and snow loads, these trusses, as near as I can tell, are these double fink trusses. And I talked to the engineer this morning, and he confirmed that double fink truss is always just going to be bearing at this end and this end, with no downward loads in the middle. So those walls, none of those walls on your first floor, on that main floor, are load bearing, according to that information, that those should be clear span trusses, 32 feet out to out. So that said, I have ignored anything to do with the roof loads, and if you like, I'm going to send everything over to the engineer, and he can provide his feedback on all of it. And that's part of why this film is put together, and that's why I'm going to try to keep it brief, so that he knows what I did and he knows what's happening out there thoroughly. So when I came out yesterday, this is what I found. I didn't dig down. There was a good 4 inches exposed above the gravel, but it's too hard scrabble dirt under there to figure out exactly how thick these are without dedicating oneself to it with a shovel. But that said, that's what I found, is these 16 by 16 CMU pedestals on these roughly 28 by 28 footings, 2'4" by 2'4", and we're just going to assume that they're 8 inches thick right now. The main beam is 4 2x10s, and I have this labeled as SPF, but I really don't know what that species is going to be. And this is what they look like. This is looking toward the front of the house, looking east, with these joists traveling back here. But I do see that they have bridging midspan. Presumably that happens on both sides, because I didn't look for that specifically. This is how the 16 by 16 pier looks, and there are 4 members here. It looks like 3, but there are 4. And this is this 28-inch footing, 2'4" by 2'4" footing. And you can see there's 4 inches above, and I assume that there's 4 inches below. This is the end pier at the west, or at the north end, the half column, or the 8 by 16 half column. And this is the main beam here, beam A, and this is these joists. And you can see this, you might be able to see this blue ribbon that I've tied here, and when I tied this from the end of what will become pier number 1 to the right end, to the north end, there was a 3/4 inch gap underneath that. You can see it here, and it's stretched from the pier that's 1 further down. Here's a pretty good look at beam 0A, the lumber for beam 0A. And here's an even closer one, a little more magnified here, but you can also see in this little series of photos this plumbing work that will really have to be diagrammed and made sure that's not going to be in the way of any ultimately proposed solution for that. So some of that will have to be laid out and diagrammed as well. And there's that ribbon with the 3/4 inch drop. And I mean, this looks like SPF, but I'm not sure that matters. In any event, I'll continue. And you'll see why that wood species may matter going forward. So just ignore what I call out when I call this out as any kind of a wood species right here, because I changed that. These dashed lines represent the walls on the second floor from the kitchen, around the kitchen. This is the range, and the countertop, and the refrigerator, and the sink and dishwasher here. But the way I've labeled these joists is thusly. These ones in the entry hall are J0A. The next ones that become the area of real concern in the center part underneath the dinette in the kitchen, this side of the kitchen, are going to be called J0B. And then over here in that living room underneath the family room, those are going to be J0C. Additionally, the ones all through here will be J0D. But we will get a little bit more of that, and hopefully not too much of it going forward. Now you can see I've just changed that species to label these like that, and added some various spans in, and we're just going to ignore all those trusses. And then I began to look at some of these members and see whether or not they were going to be passing. And first I looked apparently at J0B, the one in the center, okay, which is 16 foot and has this wall load on it here from the partition. So those are the ones that are going under that partition. And when I select all the available wood species with this 9 1/4 height and a 16-inch spacing, which is what you have in one ply, we only get a couple of those that pass. And I don't know if those are Doug fir or hem fir or not. But these two here, this Doug fir number 1 and hem fir number 1, pass for that, like that. And those are the only two that do pass of those wood species. And so then I went to A. So you can see that one there, is a close call depending on the wood species. And I don't think it's Doug fir number 1 or hem fir number 1. I just don't. I don't know enough about wood though to tell you. But then I went to A, which is the one under the entry hall, that has some issues, as you know. And the only one that's passing there is Southern Pine number 1. Now they very well may be not Southern Pine number 1, but that J0A, and I don't want to make this confusing, but J0A is these sections through here. These ones here, this loading here. Here's J0B, J0C. We get through A, 2 or 3 of those choices pass. Most of them, all the ones that are passing, are number 1 grade for J0A. Then when I come back to J0B, and what those people told you may have some validity, but I added the loading of the granite countertops in that area where those are on those joists. I eventually make this a special joist, specially named joist, J0B2, that accounts for the weight of that granite. It's an extra 16 pounds per square foot dead load. And when I do that, nothing is passing. And if I double it up, then some of these pass. Again, the Doug fir number 1 and hem fir number 1, but also Southern Pine number 1 passes if they're doubled. But it is usually not very practical to try to get those doubled after the fact. But a double joist for J0B, where those granite tops are, works. And a lot of this leaves aside or out of the equation the idea that that kitchen may be relocated here, there, or another place. And I will cover that just very briefly at the very end. And also, even if some of these solutions where I'm talking about doubling joists aren't viable, right now I'm just trying to get everything to pass so that we can design the main beam and see how that's doing. And these members have to pass for that to happen. But so next I went to J0C, which is the joists underneath the family room, the one with the fireplace, and selected all the selections. The loading is uniform, 10 pounds per square foot dead load and 40 pounds per square foot live load, and selected all the wood available for that. And again, most of them pass. And as you know, that is the area that I didn't find that was level across that area. So our problems really are located with J0B and J0A joists. And you can see if those joists are any of these wood species, then it passes. If they're one of them other ones, it doesn't pass, but it's kind of a close call. For J0D, which is over in the living room, in the main long room, very simple, all the way across, just like that. 12 pounds dead and 40 pounds live. All the selections, and you get about half of them to pass. Again, the number 1 grade passes on any of those species. So I got those all to pass just so that we could design the rest of this job, design this beam below these 4 2x10s, beam 0A, the main floor girder. And I started off by designing that as a full-length member. And this is the spans that I input. This 10-foot 10, 12-foot, and 11-foot 2 or so. These are section views A and B, and this first one, section view B. So these are all J0Z, and those are all passing, marginally, but they're passing. And that floor is level, as we know. These are going to be all J0B, and then these are all J0A through here. And for beam 0A, these are the spans and the situations. And I've put 5.5-inch bearing because that's going to be required because of the load. So I am acting like that at least 5 inches of bearing is happening on each of these. I didn't check that out super close either while I was down there. So that's how the diagram sets up. And then I come back here and I refined exactly what these loads are. Added a short joist here, just changed things around where we were getting exact information from this east side of the place and from the west side. And so you can see that now J0D is only used up to the beginning of the kitchen. And then I use, in order to test this beam, then I'm using the actual what's happening, which is this joist here with this partition load on it and some of that kitchen and granite load as well. So these become kind of a mirror of J0B2. And then it's the regular ones, the J0D, through the middle of the kitchen, and on the left bank, more of these heavier ones here, this heavier loaded ones, J0B3. So, and we can come in here a little bit close, and this is how I have arranged the loading on this beam according to this diagram here, and then transferred the values from these various members onto that. And this is just adding that's just the kitchen. That was that last joist, J0B3, which is going up this way and through here, basically the west side of that whole house on either side of the kitchen. And a little short family room joist also done. Back to the main girder design and start adding on the loads. These are all the family room loads over here first, the first couple, and then we add on the left side of the kitchen, the south side of the kitchen, go through the center of the kitchen and the right side of the kitchen with all these various loads down here at the bottom. And that gets us over to about here. So J0A2 was, I decided to add yet another member for this little section in here, so that we had accounted for this double partition here with these pantry closet wall loading on J0A2. And then do whatever it takes to make that pass, because that's heavy, so I have to double that to make that pass. But then I'm able to complete this build here with these various loads all the way to the end of that beam, to the 34-foot length of that beam. And these are these. Then I go here and select 4 plies, all the members, and 10 1/4 or 9 1/4. And the news is grim on those girders according to how I have diagrammed this and put together this loading and had this program test those numbers. The numbers are grim with that, and it's on the reaction at that end, which doesn't have enough. It needs some more. So I believe that was when I increased that bearing capacity to 5.5, just to make this work. Assume that they are bearing on 5.5, and once you do that, this is the only thing, and this, all of them still fail, and they all still fail on the moment at 10'10", which is that left side of that beam, or the left side of that right here is where they want to fail. So first of all, I went and separated out that left end because we knew this was doing okay here. So I separated out that left end of the beam as beam 0A, just to do that analysis just for that left end. And again, a couple of those species pass, but we've talked about this. 4 hem fir, 4 Doug fir passes, but nothing else does for that beam over there. But we are not really having a headache over there right now. So those are the two choices, and as I said, I don't think that's Doug fir or hem fir down there. I think that's southern pine. So I kind of ignored that little section of the beam going forward for a while, but we might want to remedy that as well. I think the joists are okay over there for sure, but that beam could probably use some remedy as well. And then after sizing everything and with this program, with those detailed inputs, then I just went to a simpler version, which is just to do the code, look at the code, which is what they use when they look at these prints, because they don't account for any of that special loading like I was showing you. They assume that you're going to frame it accordingly, double joists under partitions, etc. But they just use a simple table for these joist spans. And when I look at yours, the 2x10s at 16 inches on center, these are the ones that are failing. These highlighted ones are failing, and these are the ones that are passing here. Doug fir larch, but those are some nice grades of lumber, and I don't know if you have that down there. You can see a couple more in here that are passing according to their code books. So maybe it is southern pine number 1, which would not be out of the realm. 1975 was the build date. But then after that, a quick look at that, and, some of them pass, so yeah. And then looking at the girder and header spans, supporting one floor only, and we can interpolate these things since your building is 32 foot wide out to out, and you have 4 2x10s. So if your building was only 12 foot wide, the girder span would have to be, it could be up to 13 foot 3 wide apart. But with a building width of 32, that means this spacing would have to be that 8 foot 3 for your building, according to that simple input. And you can see we're not approaching 8 foot 3. So according to both the program and this chart, we were failing here for sure, and there for sure. And this one is a little different because it doesn't go that whole 32 foot span. That one is going to be a lot more like a 11 or 12 foot wide building. So we're okay there because your span can be 13.3 right here. So I'm thinking that this span is okay. And the measurements and so forth that I took bear that out when I was over there. So I started marking what would be almost passing or passing with these green ellipses around the ones that are passing, or more or less passing. Okay, not failing as bad as the other ones. So I have marked these with the green ones And so this becomes our problematic area. Both the entire beam here, these 4 2x10s, beam 0A, and then these regions down through here. Not so much, yes, these regions down through here. This is going to be equal to that in terms of what is happening in this and that. And then this with these extra wall loading here. So the red hatched area becomes our problem area. The green circle ones become, I believe, passing enough. 75, it's been up for 40 or 50 years already. So we'd just like to arrest what's happening and see if we can't restore it to some condition. But looking at this from a standpoint of how to solve this, and this is that same, these problem areas carried down here through the section B, with those joists that are traveling under the kitchen and under those pantry partitions, and all of beam 0A. And that fails by a pretty chunky amount. Next thing I did though, since even if it's failing, it's still going to give you the output, these loads on the columns and on these pedestals. So the next thing I did was checked out those pedestal footings, these pieces of concrete down here. And this is what the program calculated the loading on these. This 9,620 and 10,380 on these. This one's kind of negligible. It's probably a couple grand, something like that. That one's probably fine. This is a program that tells you, you know, how big a footing you need. This does the math, and these just showing this footing size is coming through here, up here where it's square. So I updated this, and so they wanted a 2'8" rectangle down here, and you have a 2'4" for the load that's coming down there for that 10.3 tips coming down through there. They wanted 2'8", and on this one they wanted 2'7", and you have 2'4". So that one is also slightly undersized. I think, and the code people though, they just, if we calculate this simply just by using this tributary area like this at 40 pounds per square foot and 10 pounds per square foot dead load, multiply it out, and then you get new numbers for those two areas that bring this down a little bit. And so that one's passing now, and this one passes now using that simple loading that the code book, or that the code people that check it use. But here's what I found in terms of my field dimensions, slopes, and so forth. In the front entry hall right there by that pantry closet, coming across that right about here, because this is where the depression in the floor is. And one of the reasons I'm talking to you in the first place is that this person is experiencing loud snapping, popping noises, not just your normal creaking, but seriously loud noises. So that is why we are seeking a remedy at the moment. But these were, when I just used a 4-foot level, and these were kind of the field dimensions that I was taking. The ceiling was sloping down 1.25 inches, the floor was sloping down 1 1/8 on this north side of that wall, and on the left side of it, on the south side of the wall, it wasn't as severe. It was sloping down 3/8 on this side and 1 inch at the ceiling. And when I went downstairs, you move these down here, when I went downstairs, this was kind of the field dimensions that I took. With this, where it was dropping down 9/16 and then dropping down another 3/8, and then it was traveling across level, and it actually dropped down some more, traveled across level some more, and then traveled back up, more or less something like that. I rotated that so that it's contacting, so it's something like that. And that kind of bore itself out, because when I stretched that ribbon from here to here, there was this 3/4 pretty steady all the way across to about through here. Now presumably after he gets the information, the engineer is gonna, presumably he may watch this film as well, but he will weigh in with what he feels is happening, or etc. But I want to see what I would do if I was trying to remedy these problem areas, those red zoned areas here, both with the joists and with beam 0A. And I just added 6x6 columns, rough 6x6s, because they have to be a full 6 inches wide. So they should be a whole 6x6, which is a rough 6x6, and they have anchors for those as well. And when I just broke those two spans and made sure that was going to work in the program here, is breaking those spans up into this sort of an arrangement here. And it does, it passes, and these are the footing sizes required. And putting that in actually reduced this one even further, so that one's in good shape there, and it reduced this one where that one is now complying as well, because it only needed 2 foot square now that load went down to 5950. So that's how I would remedy beam 0A, the end result of that. And that problem area, it eliminates that by putting these two pieces in here, like this. With this new one, or no, with this new one here, and this new one here, cutting those spans in half. And we will talk at some point, the engineer, hopefully he will be the one that will weigh in on whether or not this thing can be lifted up and how that might be endeavored to be done. But that, assuming that remedies this through here, that leaves, these joist areas here. And to me, if I was trying to solve this, this is how I've done it. I have just poured these little interior footings, 6 inch thick by 1 foot wide interior footings under these problem areas, and then build on top of those little short treated lumber walls. So we have this dashed line as the 6 inch thick footing all the way around here, and then this green is that framed walls on top of that, up underneath these kind of problematic joists down through the center of the kitchen, which is understandable that they're problematic through the kitchen, because they also have the partitions at that point as well. And that is what, if I was going to be suggesting something, that is what I would be suggesting going in. And there's about a half of a yard of, there's 14 cubic feet of concrete, which is about 20 bags, I think, or 23 or 4 bags probably, if somebody's going to mix it by hand. But about a half a yard of concrete wrapped up in these new footings, this one, that one, and then these 4 here. But probably, and I would really just form them and order this from Mini Mix and cart it in there and be done. But start looking at this from the overhead, and depending on what might do with that kitchen in the future, whether this might kind of shift back a little bit here or any number of things, then it probably would make sense to extend this one some more in the event that this is at the kitchen area, that all this weight kind of stuff is moved back here some more, which seems like something that might happen if I was working on this. And so just stretch that one out to the 6'9". And that's where the concrete volume becomes close to a half a yard with this remedy here. And I didn't think there was any mechanicals in the road of what I'm showing here. And whether I come out there and lay down on my back and look up here and see exactly how these joists are laid out is probably something I would entertain, because that would probably not be a bad idea. And finally, this one on the west, I would probably shift that back as well, in line with that little short piece up on your first floor, in case the kitchen goes that way and this doesn't hurt us on our span. It probably just helps us some. Similarly, you can probably pull this one back a touch if you want it as well. Right now I have it right underneath that upper wall. And so this is what section B looks like. You can't see these new footings in the background under those walls, and then the little short walls going up, and from the other end like this. and you see them here. The new ones is 1, 2, and then these 4 here. But maybe that is all not needed. Maybe it's all just too much and overdone. But that's what I would be showing if I was on my own. So we'll see if we get any other advice from the engineer. And yeah, lastly, I was going to say, that's why I was talking about laying on my back and seeing, or whenever someone does this, they can adjust these depending upon how these joists are laid out to pick up the important ones. And that is it. Hopefully that was not too long or too confusing, but it should give you a better idea about what is happening down there. Now I can't really, mainly because I haven't looked it up yet. In terms of lifting that, it's the beam that must, because you would technically want to lift it before you do some of this work, and near as I know it's a drawn out process, but I don't know that it has to be a 3 to 4 year process. But I don't know that either, so I'm not an expert. But I guarantee it'll be the very next thing that I start reading about, just so that I know. I'm curious now. That is it though for this film, and I'm going to put together very quick little drawings showing some of this stuff for the engineer, the floor plans and the section views, and we'll see. He will presumably provide some sort of cost basis and then update us according to what you think going forward. So that's it for now. I will talk to you soon. Thank you.